The block of disturbances. Now it's fine. Okay, so okay, 1 hour 30 minutes left. Let's begin. Capitalize the title. You are given a string title consisting of one or more words separated by a single space. You are given a string title consisting of one or more words single space where each word consists of English letters. Capitalize the string by changing capitalization of each word such that if the length of the word is one or two letters, change all letters to lowercase. Otherwise, change the first letter to uppercase and the remaining letters to lowercase. Okay, then the capitalized letters. So this will be what C and then all of them this. Change all letters to lowercase, right? So the length of the word is one or two letters in that case. So, for example, in this case, this will be of all of them will be small, one or two letters, right? So small. Okay, okay. Change all letters to lowercase. Okay. Hmm. Let's see. What I think that's very simple. Let's say my answer is this for word in title. I say that okay, if the length of the word is equivalent or the length of the word in 1 comma 2, in that case I say that okay, let's loop over this thing. So it's nothing but I guess word itself. So I simply say that for value in s, or let's say for value in word itself. So for value in word, I say that okay, s plus equivalent to value dot lower. I think so this should work if I'm not wrong. There's nothing problem to me. Huh? And then else I say that okay, f is empty, and then for value in word or s is empty, I simply say that okay, f plus equivalent to word of 0 dot upper, so in uppercase, and then for value in word from 1 till the very end, I simply say s plus equivalent to uh, value dot lower, and then end of the day I could say answer dot append, um, answer dot append, probably yes, and then I have to simply return this dot join answer if I'm not wrong. Let's see. Yeah, that's something I have to return. Use example test case as run code. Capitalize the title first letter of each word. Your input is this, your answer is this. Okay, I see what could be a possible problem. There's a lot of space here, right? Um, so what's happening? If I do simply dot join this, then now it's kind of fine. Capitalize the title. Um, so C should be upper, right? Word of 0 dot upper. Why is this not working? Oh, I see. So I have to probably do something like this. Title is equal to title dot split, but I have to split it on the basis of space, which I was not doing earlier, so that's why it was not giving me the correct output. Capitalize the title, first letter of each word. I love lead code. Yeah, I think so. This should work fine. Let's submit this. Accept it. Mute this thing. Okay, and let's go to the next problem. Maximum twin sum of a linked list. In a linked list of size n, where n is even, the ith node 0 index of the linked list is known as the twin of the n minus I n minus 1 minus I or n minus I minus 1th node if 0 is less than equivalent to I is less than equivalent to n by 2 minus 1. For example, if n is equal to 4, then node 0 is the twin node of 0, node 3, node 1 is the twin node of node 2. There are only nodes with twins. Okay. The twin sum is defined as the sum of a node and its twin. Okay, given the head of a linked list with even length, return the maximum twin sum of the linked list. Only the head is given, right? Acha, okay. So I pick 5 and 1, 6, 4 and 2, 6. So answer is 6. I pick 4, 3, 7, 2, 2, 4. So out of 7 and 4, 7 is the greatest. Okay. So I think so I can just simply access the values and then end of the day I can do it right. But how do I do it in a big of one time? A big of one space. I don't want to occupy a lot of space here. So the linked list has this property dot next, right? We don't have dot previous. That's the problem. Else we could have converted this, right? Hmm. Or what I can do is, uh, no, then again I have to create separate one, right? If I just go the naive approach way, then very simple. Say values as this, and then I say that okay, while let's have a temp variable as head, I say that okay, while temp, so simply values dot append temp dot value, and then I say that okay, let's move temp forward. Once this is done, I have some values, something in my values. So I say max answer is equivalent to 0. And also these values are never going to be negative. Yeah, that's fine. So in that case, I say my start pointer is at 0 and that length of values minus 1. Hmm. While start is less than end, I simply say my start is less than end. I say that okay, max answer is equivalent to maximum of my previous max answer and then values of start plus values of end, and then I simply say start plus equal to 1 and minus equal to 1, and then I return my max answer. I think so this should work. One go. Simple one go. Let's see, accept it. But I wanted to do it in a very conserved space. Okay, longest palindrome by concatenating two letter words. Okay, you are given an array of string words. Longest palindrome by concatenating two letter words. You are given an array of string words. Each element of words consists of two lowercase English letters. Yeah, that's something I can see. Then create the longest possible palindrome by selecting some elements from words. Okay, create the longest possible palindrome by selecting some. Okay, what's the constraint first of all? 10 to the power 5, right? So 10 to the power 5, 10 to the power 5 into 2 is possible, yes, but into 4 is also possible. Let's see, create the longest possible palindrome by selecting some elements from words and concatenating them in any order. Each element can be selected at most once. Return the length of the longest palindrome that you can create. If it is possible to create any palindrome, return 0. If it is impossible to create any palindrome, return 0. A palindrome is a string that reads the same forward and backwards. Hmm. And it's definitely of length 2, right? Hmm. So some mathematics, maybe some mathematics involved, but let's see. So LC and then CL and then GG is there, right? Okay. So this can be 6 because I can take all of them. So LCGGCL. LCGGCL. Huh. LCGGCL. Or the other way around. CLGGLC. CLGGLC. In this case, it's saying that 8. So they are taking in TY and then YT. So probably I have to do. So if I am at character LC, then I'm looking forward to something like CL, which is there, right? Again, similarly AB, so I'm looking forward to BA. But no, there's no BA, so I won't include this AB at all. So it never may happen. So it can be something like this. Let's consider this example. So I'll put that in to the whiteboard. Mhm. Okay, got my parcel. So just 1 second. So I got some food. Okay, so what can be done here is let's take this example. So we have We have ABTY, ABTY, then YT, then we have LC, then we have CL, then we have AB. So I'm like, okay, whenever I'm at AB, I'll look for BA. So BA is not there, so definitely I will never take this until and unless both the characters are same. Yes. When I'm at TY, I'm looking for YT. Yes, YT is there, so I pick and this. So I know that, okay, in my final string, maybe I'll place it in this way. So this is empty. Okay. Now, both of these are gone right now. Ah. So if this is present twice now, so I can even have TY and then YT like this, right? Ah. So this will look like TY and then YT. Ah, it's a palindrome, yeah. So LC, so I'm looking forward to CL. Yes, both of them are there. So LC comes up here, CL comes up here. AB again, that's ignorant, right? So this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. What's the longest? It's 8 now. TY, LC, CL, YT. So how much is this? Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8. 8 is the answer. So what's happening here is that if at all I have something like TY and then YT once, both of them are once, then I can place them as follows: TY and then YT. That's it. But what if this is twice and this is also twice? So I can place it TY, YT. So what if this is thrice and this is twice only? So I can place it the minimum of these two times, right? So if this is thrice and this is only twice, so I can place um, huh, the minimum of this. So the minimum of the both permutations, right? And what if I have something like this? Yeah, what if I have something like GG, right? Or let's say AA. And AA is like, let's say 10 times. So I can just squeeze this in inside of anything. So YT and let's say TY, then I can squeeze AA 10 times here, right? So whatever this thing is, I'll always squeeze that in, right? Or no. Okay, what if I have something like AA is 5 times? And then let's say GG is for 2 times. What will happen in this case? Will I be always able to put this in? So let's say I had a TY and then a YT here. And let's say A is for 3 times. So probably I can have a AA here and an AA here and an AA here. Yeah, this could be one thing. And then what about GG? So GG could be put in here, right? Yeah, so you can put all of this together, right? What if GG was only once? Okay, this is the only problem which I'm going to face right now. Key, let's say A is probably, let's say 10 times, or let's say A is 3 times, B is let's say A is 3 times, BB is 2 times, and then CC is 4 times. So how will I place this and how do I get to know? So let's say there was a TY and YT at both the ends of the palindrome. Then maybe I can, so whenever, okay, so odd mein how many times that's occurring? That's thrice, right? So whatever the thing is even, right? Even count. I will blindly put it in. So BB can be put up here. Then CC twice, my bad, and then CC. This is done. So whenever I see that's 3, so I can probably squeeze this inside, right? But what if I had one more of this? What if I had one more of this? So let's say A is once again. So let's say AA is occurring twice, and then let's say CC is occurring 5 times, and then BB is occurring 4 times. And let's say there was a TY and then YT. So how will I put this? So again, blindly BB, and then BB. How will I fill this remaining space? One way is key, okay, I blindly put all of these C's. So 5 into 2, 10 C's come here. Or I put blindly all of these A's. So 2 into 3, which is 6 AA's come here. Or 6 A's come here, right? So in which of these will my string be the longest? In this one, right? But I can also do this, that I'll pick 5 and then maybe I can reduce this down by 1. So CC is, let's say, occurring only 4 times. So I can form CC, CC, and then CC, CC, and then followed by all these A's. This could be the optimal way. So I kind of want to put sort the odd occurring same characters in ascending order, and then pick from 1 till the very end n, and take the even count of it and put it in, and for the very first one, which is a of 0, put it in odd times. That's it. Yeah. That could be, that is very optimal, yes. Uh, so first of all, I need to do this key. So let's say I'm saying that same is probably okay. So let's say same is probably this thing, or let's say my current app map is this, and let's say my same is going to be get same, and I'll pass in my words here. So let's define this get same function. Let's expand this a little bit. So this will look something like this: get same, and then my words, which is like, let's say, a is there. So how is this taken in as input? It's probably this thing, right? So I simply say that, okay, for value in a, if value of 0 is equivalent to value of 1, in that case I say that, okay, let's have a hash map here. So I simply say that, okay, if value not in hash map, then hash map of value get initialized to 0, and if it's already there, then simply increase its count. End of the day, I simply need to say keep, let's say my temporary array is this. For key in hash map, I simply say that temp dot append. How will I append the values? I'll append first the number of times it's occurring, right? Which will be hash map of key followed by, I guess, the key itself. Because do I need the key? No, I don't need the key. That's it. Hash map of key is only required. And then I say that, okay, let's sort this. So temp dot sorted, and then I return temp. That's it. This is how I get the same thing, right? So this is going to contain a bunch of information. Yes. So let's say my answer was initially 0. So right now I'll update my answer as follows. So answer plus equivalent to, or I can simply say if length of same, then in that case I say that, okay, answer plus equivalent to same of 0. Yes. And then I say key answer, or let's say for value in same 1 till the very end, if length of same. Okay, do we get the problem here? Let's see. Let's say I had an array A, not an array but a list. So if I say key for value in A of 1 till the very end, and let's say I say continue, will this be a problem? Or let's say print value. I don't think so. This should be a problem. It's not a problem. Yes. So I don't need to double check the entire stuff. Where is it? Yeah, I don't need to check this. Done for value in this. I simply say that, okay, answer plus equivalent to value minus 1. Because it's an odd number, so definitely value minus 1. Okay, that too odd occurring, right? If hash map of p modulo 2, in that case this answer is 0. else I say key. Simply put it in from plus equivalent to hash map of key because it's even number of times, and then I return this as well. So I get some value and I add that to my answer as well. That's it. So अगर even है then I'll probably just take that in and then uh, let's इसी को ही optimize कर देते हैं ना, यहाँ पे लिख देते हैं कि if that's the problem then I don't have the sorted thing. Okay, anyways, so this is what it will look like with respect to the same values, something like, let's say GG is there or A is there and then so on. Now apart from that, what do we have left? We have something like YT and then TY, right? Let's have a hash map for that as well, and let's simply create this thing. Mm, let's assume that okay, this was a set of words. So I simply say that okay, for value in probably what do we have, words, for value in words, my bad, words. So this is value 1. So what would be the value 2? Value 2 would be value 1 but a reverse of it, right? Or it will be value 1 of -1 plus value 1 of -2. That's it. Now I simply say if value 1 is equivalent to if value 1 is not equivalent to value 2, yeah, that's the case here. So this is say AB and value 2 is BA. So if they are not equal, then I know for a fact I have to do something. If value 1 is not equivalent to value 2, and let's say value 2 in S, which means okay, there is a what do we say, there is something which is existing there, right? So this could be in S only. In that case I say that okay, hash map of value 1 to equivalent to words dot count value 1, and then hash map of value 2 is equivalent to words dot count value 2. That's it. Even up here I can simply say answer plus equivalent to the minimum of these two guys. So that would be hash map of value 1 comma hash map of value 2. So I don't think so I need to even store it in a hash map. So let's get rid of that, and let's say this is my temp value 1 and this is my temp 2. So I take the minimum of that. So let's simply do that. This is temp 1 and this is temp 2, and I think so by the end of the day I have to return my answer. Let's see, use example test cases, run code. 3 4 1 we got no, it's not 3 4 and 1. Okay, so we return answer into 2. That's it, answer into 2. So run the code, 682, and that's something we are getting. So let's try to submit this. Accepted, yes, I knew it. इसमें यही था logic that कि over here the main functionality has been done, this is nothing. So yeah, this is nothing, this is the main thing here. So how do we handle odd number of cases and even number of cases, right? So 3 done. Let's start with this one, stamping the grid. Okay, so you are given an m into n binary matrix grid, okay, where each cell is either 0, empty or 1 occupied, right? So it's empty or occupied, empty or occupied. क्या लग सकता है empty occupied? Floids नहीं, second detection तो नहीं लगेगा. Let's see. You are okay. So you are then given stamps of size, stamp height into stamp width. Okay, we want to fit the stamps such that they follow the given instructions and given restrictions and requirements. So I have a stamp of like the given height and width. So it could be a rectangle or a square. Cover all the empty cells. Yes, definitely I need to cover the empty cells. I don't need to place the stamp on this occupied cell. Do not cover any of the occupied cells. Makes sense. We can put as many stamps as we want. Yes, we can put 100 stamps, right? Stamps can overlap with each other. Okay, okay. Stamps are not allowed to be rotated, so they are not allowed to be rotated. Something like 4 cross 3 cannot be 3 cross 4. Or let's say the stamp is 4 cross 10, then it cannot be 10 cross 4, right? It cannot be rotated anyway. Stamps must stay completely inside the grid. Yes, so they should not go out of bound. Okay, these are the few things. Okay, return true if it is possible. This is in the mode, right? Return true if it's possible to fit the stamps while following the given instruction requirements. Otherwise, return false. So I think so. I just simply need to probably yeah, I probably need to cover all the empty cells, right? Yes. End of the day, all the empty cells should be covered. And then we have only one stamp height and stamp width, so it's really helpful. If there were many, then it would have been a little problem. M and N is 10 to the power 5, so I cannot go M into N, right? No, I cannot go M cross N whole square. So I cannot go M cross N whole square. And this is 0 or 1, it's very simple. Stamp height, stamp width is also 10 to the power 5. So let's see what can be done here. So in this case, it was simply 100, 100, and so on. So the answer is true because I can cover all of them, right? And then we have two overlapping stamps labeled 1 and 2 in the image that are able to cover all the empty cells. Stamp height is 4 and stamp width is 3. So 1, 2, 3, 4, 5. Let's try to draw the diagram. So this is the grid. 1, 2, 3, 4, 5. So this is 1, 2, 3, 4, 5. Again, this will be 0, 1, 2, 3, but let's kind of ignore it. 1, 2, 3, 4. So that's 1, 2, 3, 4. So that's 1, 2, 3, and 4. Okay. And these are filled. So 1, 1, 1, 1, and 1. These are filled. But these are empties, right? So 0, 0, 0, 0, 0, 0. Okay, so these are empty and these are filled. So maybe for the filled, I'll just highlight this. Right, okay, this is filled. So my stamp size is what? Stamp size is probably 4 cross 3, which means it is like this, right? And this length is 4 and this length is 3. This breadth is 3, right? This is 3 and this is again 4. So if I place the very first stamp, it might occupy a place like this. Let me quickly format this thing and use a different lighter color. Yeah. So if I place the very first one, it could be placed here as the very first one. So it's all covered, right? And then the next one, I can just simply place it up here. So now it's all covered. So right now this is covered, that's covered. So probably I can say that this is the very first stamp and this is the second stamp as well. So this is what they are showing in the diagram, right? Yeah, and so on. Okay. What about this one though? We have this thing and then stamp height is 2 and stamp width is 2. Output is false. Okay. Expression, there is no way to fit the stamps onto all the empty cells without the stamps going outside of the grid. Think about this. Think about this. What can be done? Think about this. So stamp height is 2 and stamp width is 2, right? So probably okay. So if I'm at a particular location, right? Let's say this is the grid. Let's say I'm at this location, right? Or let's say I'm at this location and there was a 1 here and there was a 1 here, 1, 1, and then so on, diagonals are 1, right? And let's say all of these are filled, right? All of these are filled. And let's say these are the empty spaces left to me to operate. And let's say stamp size is 2 cross 2, which is literally this 2 cross 2, right? This is 2 and this is also 2. In that case, I think so. I cannot probably draw a stamp in this way, right? Because this is filled. What could be done? It could be BFS or a DFS algorithm, BFS or a DFS. Much better would be BFS because it's going to go breadth wise instead of depth wise, right? Okay. Let's say I'm at a grid which is having a coordinate x comma y. So in that case, if the stamp is 2 cross 2, then I know this one is the number of rows I need to access. This is the number of columns I need to access. So without like even thinking blindly, I have to simply say that, okay, let's go from this cell. If this is let's say 0 comma 0, then I have to go to one more cell which is at 0 1 comma 0. So yeah, I need to go to this and I need to check that okay, this cell, and this cells are not occupied, right? Are not occupied. Yes, I need to just check that. If they are not completely fine, move on and go to the next empty cell, and then from there onwards try to fill it. Ah. Now let's say I reach a situation wherein 2 cross 2, and let's say these two guys are empty, and I reach here, so I can probably fit in one more like this, right? They can overlap. Yes, they can overlap. So the thing here is that in my visited now, I need to keep track of what. Okay, in my matrix I need to see that okay, if it's 1 then it's problem, else let's say I can simply have something like a v, which means visited, right? If it's 1 I don't need to operate, if it's v then I don't need to operate. Done, done, done. Ah. This can be done for sure, but again like acha, m cross n will be less than equivalent to 2 dot 10 to the power 5, which is sweet. Okay, so yeah, I think so that can work. So let's try the bfs algorithm, right? Bfs algorithm. So what could be the way, what's the time right now? 23:18. So how much time did I begin? I think so I began 36 minutes ago. It's great. Okay. Let's say if I can do it or not. Let's say that can be determined by the variable flag, or I can have my result as follows. So my result is solve function, and I'll pass in my grid, my stamp uh, height, and then my stamp width, right? If I'm not wrong with the spelling, yeah. Grid Samsung, and this is passed. I simply return my result back, which kind of makes sense. So let's have my function here itself, and I'll just redeclare these variables. So instead of grid, I'm comfortable with matrix M. Stamp height, I'm comfortable with H, and with I'm comfortable with W. So I simply say that okay, let's do a BFS rotate. So that would look something like this. That okay, for I in range, let's have n, by the way, n is the length of matrix, and then n is the length of matrix of 0. So I simply say for I in range n, and then I say that okay, for j in range m, I say that okay, if matrix of I comma j is equivalent to I guess 0, in that case what do I do? Yeah, if it's equivalent to not a string representation of 0 but simply 0, this means this node is unvisited, right? Unvisited. Okay, now the thing is not unvisited. Okay, the thing here is that I could land up at an orientation like this key. Let's say this, and this. Let's say this is occupied by some measures. This is occupied here, and then let's say this is occupied here. This is occupied here. So from here, I simply don't need to go in this way, right? I need to check for every single way. So I have to make this all four corners, all four corners. So I simply need to check the corners, right? And within that corner, I need to check that, okay, if there's any ones present or not. That's it. Okay. So if the stamp height and width is this, and I'm at this cell, I'm at a particular cell, let's say x comma y, then I have to treat that cell. Yeah, I have to treat that cell as one of these points, one of these points, one of these points, one of these points, and try to form the uh, thing around all. So this could be a point wherein I have to form like this. This could be a point where I have to form like this. This could be a point I have to form like this. This could be a point I have to form like this. Okay, so I just need to take care of the corners, and using, I guess, a prefix thing. Yes, prefix thing. I can get the value that, okay, if there is any number of ones in between that or not. Yes. So here I cannot do a BFS or something like that. No, no, no. BFS is not required. We have to create a prefix one. Definitely, we have to create. We have to. So let's create that thing. So let's say my prefix is probably zero right now. Yeah, zero for I in for I in range m, and then this will be followed by for j in range n. Looks good. How will this prefix be populated, by the way? So let's say my matrix was something like this. Let's say I had a one here and then a one here and a one here and then one here, and the rest of them are zeros, right? So how do I know that in a given range there are no ones, right? I think so. That could be found out using this key. ओके, हाँ यहाँ पे वो भी लगेगा. Okay, so यहाँ पे ये लगेगा. So if I'm given the corners of something, right, I can find out the sum of this rectangle, and if the sum of this rectangle is zero, I know there are no ones. Beautiful. Okay, I have to watch a dynamic programming problem, right? Okay, so okay, how did we use to fill the value? By the way, it was done in this way. So if there's a one here, a zero here, okay. So let's create this. This is nothing but a DP. Okay, this is a DP. So I simply say that, okay, DP of zero of zero. That's matrix of zero of zero. Then I loop here. So for column in range one till m, yeah, one till m, I simply say that, okay, DP of zeroth row, but this column. Let's simply add the value of the previous one. In this case, that will be dp of 0 but of column minus 1, and plus I'll add in the current value, which is matrix of 0 of this current column. Beautiful. Now I populate the rows. So for row in range 1 comma n, I simply say that, okay, dp of this current row, but the same first column, that will be dp of the current row, and the previous so previous row minus 1 and then 0, followed by matrix of probably row and right. So this is how I populate the row and column, right? So dp populate ho chuka hai. Done. Okay, now I need to populate in this way again. So for I in range probably 1 n, and then for my bad, so that will be for j in range 1 comma m. What do I need to do? Let's see. So if I'm at this point, how do I populate? I say that, okay, this has some value x, y, and z. I know this is the value of this whole thing. This is the value of this whole thing, right? So I simply add them. So I say that, okay, y plus z, but I subtract this because I've taken this again. So x followed by plus the current value, which is matrix of. So I'll simply say that, okay, dp of ij will be matrix of ij. My bad. Matrix of ij plus dp of probably previous column, right, which will be I j minus 1, plus dp of previous row, that will be I minus 1 and then j, and then I'll subtract the corresponding, what do we say, I'll subtract the corresponding um, diagonal, that will be dp of I minus 1 and then j minus 1, right. uh, so this is populated for like 100% sure this is populated. This is populated for sure. Now, how do I get the submatrix sum? So let's say this is my matrix and I need this sum. So what I do is I get the entire sum here, which is ending at this location, which is like dp of this row 1 I'm getting, right? This is row 1 and column 1, and here I'm getting row 2 and column 2. So I simply say that, okay, dp of row 2 and column 2, I simply add this. This is the entire thing. From this I subtract this location, which is probably row 2 column 1. So this entire segment gets subtracted. So minus dp of row 2 and then column 1. Yes, this is subtracted. Now I subtract this one, which is probably row 1 and then column 2, right? So I again do minus dp of row 1 and then column 2, and then I add this back, so that will be, to this I'll add plus dp of row 1 and then column 1. That's it. So I'll use this formula. Okay, I'll use this formula. Okay, this is populated. So for I in range n, for j in range m, if matrix of I j is equivalent to 0. So I just need to simply check for if any one of these guys is valid, right? Yes, if any one of these guys. So check in all possible 4 directions. So let's say my currently I'm looking forward to this one, right? So let's say x comma y is located here and I'm looking forward to that. Okay, this might be the point. Let's say this height is h, this is w. So let's say this was 0 comma 0, height is 2. Then I will look forward to this row 1 comma 0, 2 comma 0. So how much is this being increased? So I'll say row 1 and column 1 is what at the very first instance. Let's say all my possible directions would be what? Corners will be what? Let's see. Corners will be probably x comma y first, which is I comma j here. And then the rightmost corner will be what? The rightmost corner will be this one, right? What will be this corner, by the way? This will be, this is going to be, let's say height is 2 cross 2, right? Height and width. So in that case, 2 cross 2 itself, right? So how did we get this? It's probably I plus h and then w plus j. So I say that okay, I plus h and then w plus j. It kind of makes sense because if I'm at 0 comma 0, then so let's say this cell, right? So 0 comma 1. So from 0 comma 1, how do I get to this cell? It's 0 plus 3 or 0 plus 4. So 0, 1, 2, 3. 0, 1, 2, 3. Okay, my bad. So this will be probably minus 1 and then this will be w plus j. Yes, makes sense. So 0 plus 3 and then 0 plus 1 plus 2, which is 3. 3 comma 3. So 0, 1, 2, 3, 0, 1, 3. Yeah, 3 comma 3 and then 0 comma 1 is the starting point. Yes. So this is one of the starting points. Yes, this is one of the starting points indeed. What's the other starting point, by the way? Let's see. There will be one more. There will be one more. There will be one more. So let's say my point was this, right? My point was x comma y, and this is, let's say, 0 comma 0, and height is again 2 cross 2. So how do I get the two corners? The bottommost corner will be what? The bottommost corner will be probably I comma j itself, and what will be the topmost corner? Topmost corner will be probably I minus h minus 1. Yes, so I say that okay, so the I minus h minus 1 followed by j minus w minus 1. So probably if I'm up here, which is 0, 1, 2, 3, 4, 0, 1, 2, 3. So I'm at 4 comma 3, right? So if I'm at 4 comma 3 and height is this, width is 3. In that case, let's get it to 3. This is 2. This will be what? Topmost corner will be 1 comma 1, right? So yes, 0, 1, 1 comma 1. This is the topmost corner. Yes. So it's completely fine right now. This is the very second one. What if my point is this point? What if my point is this one, x comma y, and let's say this is 0 comma 0 itself. So one of the right hand side corners will be what? It will be it will be, I guess, x comma bottom right corner will be x comma, or let's say I comma y plus w minus 1. and then this corner will be simply um, uh, x minus h minus 1, right, comma y. Yes. So the very first point will be I minus h minus 1, and the second point would be this is going to be j itself. The second point would be uh, I as it is j, and then plus w minus 1. Okay, the last one, what if I'm at this location, right, 0 comma 0? So how will I get this? Let's say this is I comma j, then this will be simply I plus h minus 1. So the bottom right corner will be what? So the bottom right cell will be probably I plus h minus 1 comma jth column itself, and this one will be probably I minus h minus 1 comma so this will be I itself, by the way, and this will be j minus w minus 1. That's it. So these are all the like directions, right? And probably I'll take this in and put it here. Directions. So it might look complicated, but it's very simple, right? So check in all possible 4 directions. So if there is possibility, then it's fine, then all good. So I say that okay, for value in directions, so I'm at the very first value right now, right? So I say that okay, my row 1 is, or my row 1 comma column 1 is probably value of 0, and then my row 2 and column 2 is value of 1. Now I simply check that okay, all of these rows are valid or not, right? So it's very simple. If like 0 is less than equivalent to 1, define valid I comma j comma n comma n. So if n and 0 j n, in that case I return true, else I'm happy enough to return false. So instead of doing the naive way, I'll say valid row 1 column 1 n and m, and valid row 2 column 2 n and m. Yes, and if these two guys are valid, then I'll check that okay, and get sum of row 1 column 1 row 2 column 2, and then the dp I'll pass in is greater than 0. In that case I know it's not valid, so I simply return a false here, right? Or if it's equivalent to 0, I know that okay, it's completely fine. So I'm like okay, move forward, right? Let's move forward. So I say that okay, once it has been found, once is 0, so I will say that okay, once is 1, and then I simply break out of this. So if once continues, else I say return false. End of the day I have to return true. And then I have to create this function as well, define get sum, wherein row 1 is provided, column 1 is provided, row 2 is provided, column 2 is provided, and then this dp is provided. So I simply say that okay, my value is dp of row 2, column 2, and from this I'll have to subtract few of these things. Let's see. So where is my dp table? Where is this? So here I subtract dp of row 2 and column 1. So okay, so I have to do it in this way. Column 1 minus 1 is greater than equivalent to 0. Value minus equivalent to dp of row 2 and then column 1. And then here as well, yes, I have to check that okay, if row 1 minus 1 is greater than equivalent to 0, in that case I simply say that okay, value minus equivalent to dp of what, row 1 minus 1 and then the same column, column 2. Now since I've subtracted it twice, I'll add it. So I'll say that okay, if probably row 1 minus 1 is greater than equivalent to 0 and column 1 minus 1 is again greater than equivalent to 0. In that case I say that okay, value plus equivalent to dp of row 1 minus 1, that's the diagonal itself, column 1 minus 1, and then I return the value. Yes. Lot of things going on here. I don't know. Use example test cases, run the code. I think so this will be wrong at the very first instance. True and false. Okay, let's submit this. As expected, runtime error. Local variable j reference before assignment. Okay. Okay. Yes. So definitely, let's copy this thing. I know why it's happening. So let's put this here. So directions has been again updated. Let's see with respect to these examples, last executed input. Let's paste this bad boy and then run the code. So this is actually giving me some answer right now. Let's submit this. It's better run because I'm checking in all possible directions. Okay. So expected was true, but I got a false, right? Okay. Let's try to see. 1000. I think so. This is the input itself, right? 4 and 3. So the input only went wrong, right? Okay. So this should be j plus w minus 1. Nonetheless, it's the same thing. So one of the corners is ij, and the next one is I plus h minus 1, j plus w minus 1, which is this one. Then one of the corners is ij is here. So I'm looking at this corner, which will be I minus h minus 1, which is I minus h minus 1 will be. So let's say I'm at 0, 1, 2, 3, 4, comma 1. So 4 minus 3 is 1, right? So I'm up here 1 comma j minus 2. So j was here. Three minus 2 is 1. So this is going to translate to 1 comma 1, which is 0 1 0 1 1 comma 1 is the starting point. 1 comma 1 and then um, this will be column 1 minus 1, right? Oh my god. Let's run the code again. Use example test cases, run the code. Again, it's false and false. Okay. Mm. At row and the 0 column. 0th row and the same column. Am I missing out on something here? For sure. Let's see. If matrix of ij is equivalent to 0, check in all possible 4 directions. And I think so directions is kind of fun. It is indeed. I and then yeah, I is getting closed here. I plus h minus 1, which is going down, and then j. Okay, so one of these is so both of them are valid. Then ones becomes 0, right? And then ones is 0 here. So I simply say that okay, if ones, then continue. So Okay, I kind of wanna check for this one, um, this input. So, so we have very little time left. So, when did I start the stream? It's been 22:42. It's been 1 hour and some minutes, right? So let's quickly get and try to see what's. I can see here itself, right? DP. I just need to see what it looks like. Run code. This is definitely going to be a wrong answer because I'm just checking this. So this is what the DP looks like, right? What did I write? Before running false, I say that okay, print ij, and I say that okay, print. This is the faulty point. Let's run this again. So 0 comma 2 according to them is the faulty point. Okay, so I could have considered it as the medium 2, right? So 0, 1, 2. Okay, so from here I could have considered this. Hmm. So let's say once I know that, okay, at this point it's kind of valid. In that case, I mark a certain range of cells here, right? I say that, okay, let's say um, yeah, let's say 1 comma 1, and then let's say from 1 comma 1 till 3 comma 1, and then here it could be 1 comma 3, and let's say here it could be 3 comma 3, right? So let's say this is the entire cell marked right now. So I'll store some kind of a range so that if I'm at 1 comma 2, I don't have to process it again. So maybe once this is done, I'll store something like, okay, from 1 comma 1 to 1 comma 3, all the cells are marked. Or I can store something like this: for the first row, cells from 1 till 3 are marked. So whenever I'm at something like, oh, I'm at 1 comma 2, in that case I know, okay, okay, I don't have to put in the values. Okay, what if they are at a cell 2 comma 1? How do I get to know about this then? So I simply say that from 1 to 3 I have a marked cell, right? what could be done here? If I go 10 to the power 5 multiplied by 10 to the power 5, that will be a sin, right? So need a way to determine ki, okay, this portion of the thing has been covered. I simply need to go here, right? If I just go on marking them, all of them one by one, then it's a problem. What could be done for this? Hmm. Again, if I go for all of it, it's a problem. Or I could have a range of columns and a range of rows. Hmm. So if I'm starting at a particular corner, right, it has to be going like this. It can never go in this way. So yeah, definitely. So if it goes like this, then there are few options available. So let's say the first one goes like this, then it could be that, okay, I need to start from here. Or it could be that if it goes like this, I need to start from here. Either of the two places I need to start. And if I, let's say, go from here, I might check for this, and if it's not the case, then I check this as follows. Then I check this as follows. Now I see, okay, it's matching. So I go to this one instead of this one. What about this though? Gonna wanna mark all of these cells, but that will take a lot of time complexity. It's 10 to the power 5 already, and then stamp height is also this thing. Acha, okay. Could be done. Okay. Not related to the set. Or in matrix itself, I'll do that, right? अच्छा नॉट रेजिडेंट में चलता है ठीक है सो नॉट रेजिडेंट सेट it's saying if once then simply continue, right? So for False there, Habibi, right? Hmm. It's true right now, but true and false. Let's try to submit this. Might give me a TLE, time limit exceeded, or a wrong answer as well. Wrong answer. Expected was false. Expected was true, but gave me a false. Time limit exceeded, yes. How many did I pass though? 28 only passed. It's going to hurt a lot. There's a bunch of zeros, right? Then 263 cross 26303. Okay, there should be a very given way. Nonetheless, I'll take it. Um, Correct. Okay. Try to absorb this. So, I read the submetrics some that's something I've done iteration now. But Something I've done already. Okay, I'll see this right now. Just end the session now.